Hi, everyone. Today, we're going to start on a sequence of 5 different types of reactions, the first of which we're going to call synthesis reactions. Okay, if you look behind me, the 5 different types of reactions we're going to talk about are synthesis reactions, which is what we're doing today in lesson 6. We have decomposition reactions in lesson 7. We have single replacement reactions in lesson 8, double replacement reactions in lesson 9, and combustion reactions in lesson 10. As we are going through each of these different types of reactions, I would like you to complete the assignment that I have included up on Schoology. So what we're going to do is finish off the reactions by deciding what their products are, and then by writing and balancing a chemical equation for it. If you look at this general reaction behind me, we see that a synthesis reaction involves 2 reactants and a single product. Each of these reactants could be either an element or a compound. So A could be an element or a compound. X could be an element or a compound. So an element or a compound reacts with a second element or compound, producing a single product. I'm going to now show you a video of a synthesis reaction demonstration that I did with magnesium and oxygen. Let's look at some examples of synthesis reactions, beginning with that magnesium and oxygen demonstration that I just showed you. So if we take a look, our first subcategory of synthesis reactions says a metal and a nonmetal combine to form an ionic compound. So in this case, magnesium is our metal, oxygen is our nonmetal. When those 2 things combine, keep in mind a couple of things. Magnesium is going to form a positive 2 charge when it's part of a compound, and oxygen is going to form a negative 2 charge when it's part of a compound. So in this case, we're going to have magnesium solid reacting with oxygen gas, producing our product, magnesium oxide, which will also be a solid. Whenever a solid and a gas react, we're almost always going to produce another solid. At this point, what I'm asking you to do is to go ahead and balance this equation. So notice we have 1 magnesium, 2 oxygens. So that means I have to add a coefficient of 2 in front of my magnesium oxide, which means I have to go back now and add a 2 in front of my magnesium. So I wind up with coefficients of 2, 1, and 2 again. We take a look at our second example. We have an element, barium, reacting with another element, sulfur. Barium is a metal, sulfur is a nonmetal. Just on the side here, barium is in group 2, so it's going to have a 2+ charge. Sulfur, that's in group 16, so it's going to have a 2- charge. When I put these 2 together, I get barium sulfide. Barium sulfide is going to be another solid. And in this case, most likely I would have to add heat or something like that to get this reaction to take place. So now I'm going to balance this. You'll notice that sulfur has a subscript of 8. So that means I'm going to need to put an 8 in front of barium sulfide and another 8 in front of barium. Let's take a look at our third example here. In our third example, we have solid iron. That's obviously our metal reacting with oxygen, our nonmetal, and it's going to produce a compound, and it tells you in the problem here that we should use the 2+ charge for iron, because remember, iron is a divalent, so it could be a +2 or a +3. So it's telling us to use the +2 charge. Oxygen, just like we saw up here, is a -2 charge. So when we put these 2 together, once again, we'll get FeO. Once again, it'll be a solid. And then balancing this, we'll have to put a 2 here in front of FeO and then another 2 in front of iron, and we'll end up with just a 1 in front of the oxygen. Our second subcategory for synthesis reactions is right here. A non-metallic oxide, so something like sulfur dioxide, combines with water to give an acid. So water on the bottom here is H2O. That's pretty straightforward at this point, hopefully. So what we're going to do is we're going to add these two pieces together. So we're going to wind up with a product that is H2. We want it to start with H because it's an acid, H2, and then SO. And what we'll do is combine these O's. So we have 2 from here, 1 from here. So we get H2SO3. When we balance this, all of our coefficients end up being 1s. Okay, if you look at this slide, we have a third category of synthesis reactions, a third subcategory. So it says that we have a metallic oxide. A metallic oxide means we have a metal bonded to oxygen. It says it combines with water to give a base. So the base part is going to be hydroxide. So essentially we have our metal, calcium, combining with our hydroxide, which we're given in the formula. This is going to form a compound that has this chemical formula, CaOH2. We need 2 copies of hydroxide in order to balance out the charge on calcium. Once you do that, you can go ahead and add in our coefficients here. So we have calcium, we have 1 oxygen plus 1 more is 2. We have 2 on the right side, and we have 2 hydrogens on the left and 2 hydrogens on the right. So in this case, all of our coefficients end up being 1. And that's often the case with this type of problem. Not always, but often. The last piece here is we're going to add our state of matter to our product. So on your Schoology page, I'm going to provide a document called Solubility Rules. And basically that will tell you whether something should be written as solid, liquid, gas, or aqueous. And in this case, what we have is an aqueous compound because we have hydroxides, which are insoluble. We have calcium as an example of an exception. Okay, and the last subcategory here. So we have a metallic oxide like calcium oxide, combining with a non-metallic oxide like we saw before, sulfur dioxide. These two are going to come together and they're going to form an ionic compound. Now, we're going to push these all together and we're going to make CaSO. So CaSO, and then we have 2 oxygen here and 1 here. So that's CaSO3. A solid and a gas combining will form another solid. And again, in this case, our coefficients are going to be 1s. Okay, if you look on the second part of the assignment for today, you'll see some synthesis reaction practice problems. Now, depending on which level you're in, they may be completed to a different level already. So if you're in the accelerated honors level, you're going to have to predict products and tell me what you're forming. If you're in the honors level, those products are going to be written out for you. The only thing that I would like you to do is to add the names for all of them. And for my career and college prep students, the equation is there with the names. I simply want you to balance it and be able to recognize it as a synthesis reaction. So eventually all of these different types of reactions are going to get mixed up together. So I'm going to ask you to be able to figure out what type of reaction you have. So let's take a look at our first reaction here. We have cesium reacting with oxygen to produce cesium oxide. So we have Cs, that's in group 1, so it's a +1 charge. Oxygen is in group 16, so it's a -2 charge. So when we put those together, we get CS2O. I need 2 copies of cesium in order to balance out my oxygen. Notice that in this case, I don't want you to predict what state of matter we have. I don't think we're ready for that quite yet. So I'm going to leave all the states of matter off. And instead, I'm going to finish this by writing in my coefficients here. So I need 2 cesiums, 1 oxygen, one of these. And then finally, and this is the part that I would like as many of you as possible to fill in for me, we're going to have cesium plus oxygen forming cesium oxide. So cesium plus oxygen forming cesium oxide. Okay, if we take a look at our next one, we have Sr, that's a metal and a non-metal combining. So strontium is in group 2, that's 2 plus. Iodine is in group 17, that's 1 minus. So it's going to form a compound SrI2. We need 2 copies of iodine in order to balance out the strontium. Now I can balance this equation. So in this case, it's already balanced. So we have 1, 1, 1. And then we're going to follow that up by writing out the names for all of these just to continue practicing naming and writing formulas. So we have strontium plus iodine forming strontium iodide. We take a look at our third example. In this case, we have a non-metallic oxide. So a non-metallic oxide combining with water. So if you go back and look at the examples that we have there, we're going to form an acid. So in this case, the acid that we're going to form is H2SO3. When we balance this, all of our coefficients will end up being 1s here. And then we're going to write out our names for each of these. So we have sulfur dioxide, plus water, producing, this one's a little bit trickier, sulfurous acid. So the naming for acids, only Accelerated Honors is responsible for that, so I'll have that part written in there for you. Okay, last couple of problems that we're going to try together are a little bit more challenging because they're starting off in word format. So I want you to finish the equation in word format and then write a balanced chemical equation using chemical formulas below it. So in this case, sodium plus oxygen is going to give us sodium oxide. So sodium is going to be Na. Oxygen, remember, is a diatomic. So whenever it's by itself, we have to write it with this 2 here. And it produces sodium oxide. So sodium, remember, is positive. Oxygen is 2 negative. So we need 2 copies of sodium in order to balance out our oxygen. Okay, the last thing that we have to do here is balance out our equation. So we have 1 sodium, we have 2. We have 2 oxygens here, but 1 here. So I'm going to go ahead and start by putting a 2 there. So 2 oxygens, 4 sodiums. So I'm going to put a 4 in front of sodium. And then I'll just carry these numbers up here to the top. So 2 sodium oxide, that part's here, 1 oxygen, 4 sodiums. Okay, taking a look at number 8. In number 8, it tells us that we're going to use the copper 2+ or cupric ion. So copper plus oxygen is going to give us cupric oxide. And in this case, we have Cu plus O2 going to form, if it's a positive 2, Cu is 2 positive, O is 2 negative. So we get CuO as our product. Balancing this, I have 2 oxygens, so I need to put a 2 in front of cupric oxide and copper. We'll just copy these numbers into our word equation. For question number 9, we have potassium plus chlorine forming potassium chloride. And in this case, I'm going to start off with K. Remember, chlorine is a diatomic, just like oxygen, so it has to have a 2 there. And it's going to form KCl. Then balancing this, we have 2 chlorines here, so we're going to put a 2 in front of KCl and a 2 in front of K. That ends up being a 1. Now we can just copy those up into our word equation. And then finally, as our last example, we have magnesium and fluorine. That's going to react to give us magnesium fluoride. So, writing out our equation, we have magnesium, fluorine, another diatomic, going to give us, now magnesium is 2 positive, fluoride is 1 negative, so we're going to get MgF2, just like that. It's already balanced for us, so we can just go ahead and add in coefficients of 1 all the way across here. Just a quick reminder, because I mentioned it several times here, there are 7 diatomics that we need to be aware of. That means anytime these elements are listed by themselves, they're not written as a single atom, they're written as a pair. So hydrogen, oxygen, nitrogen should all appear as H2, O2, N2, and then the elements in group 17. So F2, Cl2, Br2, and I2. Anytime these elements are by themselves, like they are here, 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 and here, they have to be written as a pair. All right, thanks very much. Please let me know if you have any questions on synthesis reactions. Bye, everyone.